Yeah, I can hear you. Um, Hi all, you can hear Harsh, all right?
Yeah, yeah. Can you just please mark yourself that you are able to hear me, and also can see my screen as well?
Yeah, I can see.
Yeah, yeah, I can see. Yeah.
Okay,
All
yeah,
right.
go on.
Hi guys, this is Harsh here. I'm a AWS instructor. I work with multiple companies across the many regions. I have designed the AWS infrastructure a lot of time. For a lot of infrastructure, I designed for a small to a big infrastructure. And over the time, I've been also instructing as a AWS instructor from the Amazon side, from the different vendors as well. So my overall experience in designing the cloud infrastructure as well as in training is having multiple years right now. So we are here to discuss about the AWS cloud computing. AWS, that is Amazon Web Services. So may I know anyone having any idea about cloud computing or anyone worked previously with the cloud computing infrastructure?
Yeah, I have experience. So I'm not sure other guys. So have you worked on AWS earlier? Anyone, or it's just a first stint?
Any idea what is cloud computing basically? It's okay if you are not aware of AWS. No one? Fine. I'll give you a small example what exactly a cloud infrastructure is all about. I hope this is a very normal scenario that you have already worked on. Let's say I have a system, a Windows operating system, or any operating system. Maybe it's a Linux or a Mac machine I have on my system. I have a computer, a laptop, whatever it is. And on top of this particular operating system, I install a virtual box. Have you guys ever heard of this virtual box or VMware software? If you know this, guys, then what we do, we install this particular application on our laptop computer, and then we install a guest operating system. So for example, I have Windows operating system as my host computer. On top of that, I install VirtualBox of VMware software, and using that tool, I create another guest operating system. That may be a Linux, that may be a Mac, that may be another Windows, whatever I want. So similarly, I can create virtual multiple guest operating system on a single hardware on a single host operating system. This particular process is called as virtualization, creating a virtual environments on top of a single hardware on top of a single machine. This is nothing but a virtualization. And virtualization that can be accessed over the internet is a cloud computing. So Amazon or maybe Google or Azure or any other cloud vendor, whatever you are aware of it, all the different vendors are using the same technique. They all are offering you a virtual environment on top of the cloud. Right now, what you have, your own computer on which you have a guest operating system, you access it directly whenever you want. But this particular guest operating system is being created by now these vendors, and you can access this operating system over the internet. That is nothing but a cloud. So cloud computing is something which is you try to access a server, a resource which is taken care by the third party vendor, and you access this particular resources on internet. That is nothing but a cloud computing environment. Now, usually the cloud computing environments gives you as per the pay as you go model. The amount of consumption you do, you have to pay for that. If you are not using, you don't have to pay for that. So this is in general what is cloud computing. Now, whenever we deal with the project, whenever we have a customer who is looking for a cloud solution or who wishes to move to the cloud, every time they have this kind of question, why I should move to the cloud, first of all. And if you justify the reason why you should move to the cloud from an on-premise infrastructure to a cloud infrastructure or directly designing infrastructure to the cloud, the second question comes is which cloud vendor should I prefer? Because in the market there are a lot of cloud vendors available. So how to select one of the particular vendor which is good for my infrastructure? These are the most two important questions that will be always there whenever you interact with your clients to understand their problem and try to design the infrastructure. So in this particular scenario, in this particular session, we are going to touch a few of the points of to understand why cloud, and if cloud, then which cloud vendors is suitable for you. So AWS cloud computing. So when here we are here to talk about the cloud computing infrastructure. And whenever we say infrastructure, what exactly means an infrastructure is? Infrastructure on the cloud or any on-premise infrastructure is nothing but a combination of four core services: a compute capacity, computing requirement, that is your server, that is nothing but your computing requirement. Second is storage, to store your data, to store your different kinds of storage, your media files, etc. Third is networking, for interconnection between the entire system for your, all the different web servers, storage, and other things, the networking which is required, the internet bandwidth which is required. And the fourth most important core concept is database. Different varieties of database we have in the market right now. So a combination of these four core services together form an infrastructure. Doesn't matter what kind of application you want to run. Maybe it's a big data application, IoT, machine learning, normal web application, or e-commerce site. Whatever the applications you want to host, whatever the applications you want to design with these four core services, you can design any infrastructure you want. A computing capacity, storage, networking, and a database. The same, these four services are being provided to you by these cloud computing vendors. These are called as infrastructure as a service. What is core service which is required on the infrastructure to design the infrastructure, any kind of infrastructure that is provided by these cloud computing vendors. Now, when to select AWS? AWS has a lot of benefits, a lot of features that other cloud vendors is still failed to provide you, or they are still working on design that particular solution to meet the customer's requirement. AWS currently having more than 150 AWS services globally. More than 150 services. So what are these 150 core services? Because we just saw that we require only 4 core services. So what are these another 150 services that AWS is giving you? So these are nothing but AWS managed services, where instead of you work on something model, AWS is working on you and give you direct service. For example, a big data application. If you want to design a big data applications, then what you will do? You will have a database, you will have a storage system, you will have a servers that will, fire the queries to your database and run the computation power, etc. And in between this, you will require networking and all these things. So you have to design all this infrastructure for yourself. You need to build up a server, you need to manage all the multiple servers that you have. You need to design the entire infrastructure. Now, what AWS offers you? A direct big data service, where you don't have to do anything. You have to connect this particular service with your database from where you are going to pull the data, how you are going to fire the queries from where exactly. And once you connect your infrastructure with that particular database, you can fire the queries directly. You don't need to invest your time in designing such kind of applications. These are the pre-built applications are already available. So similarly, for artificial intelligence, for machine learning, for storage, for networking, a varieties of AWS services are available. I will just show you on the AWS console what are the different AWS services that are available. You can go through it and check it out. So AWS Cloud provides a broad set of infrastructure services such as computing, storage, networking, database that are delivered as a utility. Now, these services, these resources are available to you on demand, available in second, and with pay-as-you-go pricing. Whenever you want a server, whenever you require a storage, you can just go to the AWS console, click here and there, few clicks, and you will get your resources available within only few seconds. Getting a server on the AWS will take only 10 to 15 minutes, 10 to 15 seconds, sorry. Within 10 to 15 seconds, you will get your own server. And now with pay-as-you-go model, that is the amount of consumption you do, you have to pay only for that. If you require 2 servers only, you pay only for 2 servers. If you require 10 servers, you pay only for 10 servers. If those 10 servers are running only for just 2 hours, then you pay only for those 2 hours. The amount of consumption you do, you will get charged accordingly. And on AWS, there are more than 150 services available. So you don't pay for all the 150 services. You pay only for those services which you consume. If for a particular service, if you are not consuming, you will not get at all charged for that. So AWS gives you infrastructure services like computing, storage, networking, and database. Varieties of services are available, and that is delivered on demand basis. Whenever you require, you can pull the services. Now here is a short description about how reliable, how highly available our AWS infrastructure is. AWS infrastructure is designed in 22 different regions worldwide. A region is nothing but physically separated area across the globe. So you have infrastructure. AWS has data centers in US, in UK, in India, in Japan, in 22 different regions. And out of these 22 different regions, 2 regions are allocated for US government and China government. In this particular 2 regions, you cannot design your infrastructure unless you are designing some application for government applications. So you are not allowed for that. So total right now you have 19 regions, and Amazon is planning to come up with 3 more regions by the end of 2020. So by the end of 2020, you will have few more regions. So AWS infrastructure is located in 19 regions globally, and you can design the infrastructure in any of these regions. If you are sitting in India and your client is situated in US, then by sitting it here, you can design infrastructure in US, in UK, in London, in Paris, or in China, Hong Kong, wherever you want. There are varieties of regions available, and you can design in any of the regions. Now, in each of the region, in the AWS term, it's called ability zone. An ability zone is nothing but the number of data centers they have in a particular infrastructure in a particular region. So specifically, when I talk about the Mumbai infrastructure or in India, we have 3 data centers, 3 ability zone. Ability zone is nothing but a single ability zone is nothing but the number of data centers it can have. It can be a single data center, it can be a group of data centers. So in India, in Mumbai, we have 3 data centers, 3 ability zones. Each data center contains a lot of resources, a lot of servers, storage, networks, etc. You just request to the AWS what kind of hardware you require, and there is already the services are available there. And all these data centers are synced up together. All the regions are tied up together. So any data transmission that needs to be done between one region to another region, you can do it within only fraction of millisecond. So it's very fast. All the network, all the regions are connected to each other via dedicated private lane. So AWS infrastructure contains regions and ability zone, and ability zone will be always in the multiple format. At least in every region, you will find 2 ability zone. And the best part of having an ability zone is you can design your infrastructure in multiple data centers. In the Mumbai itself, if we have 3 data centers, I can design my infrastructure in 2 data centers, partial in the 1 data center and partial in the 2 data center. For example, let's say I want to have 10 servers for my infrastructure. So I can put 5 servers in one of the AC and 5 servers in another ability zone. And together this 5 plus 5 will work for my application. Now you must be thinking why we need to have 2 different data centers, infrastructure in 2 data centers, and why it is recommended. Having multiple servers across multiple ability zone helps you to achieve high ability, which is impossible and which is not at all feasible to design the infrastructure on an on-premise infrastructure. If you plan to design 2 data centers, it cannot be possible of an on-premise, because when we talk about the on-premise infrastructure, you have to put a lot of money there. You have to invest a lot of money in designing the data centers, in buying the resources and everything. But on AWS, you don't have to do all these things. The data center, the resources will be maintained by the Amazon. So now my infrastructure is in 2 data centers. What benefit I will get is, in case if one of the data center goes down, AWS offers you 99.99% of availability guarantee. But still, if your resources go down due to any natural disaster or calamities, anything, then AWS will automatically recover your data, which is available in the next availability zone. So for example, 5 servers I have in AZ1 and five servers I have in availability zone 2. Now, if one of the availability zones down, then the resources created in another availability zone will help and serve my application. So those 5 servers running in another availability zone will help me serve my application. So that is the benefit of having a multi-EC on our infrastructure. In detail, once we start our session, once we start our course, we'll get to learn a lot of things about AWS, about the cloud computing, other things, and how comparatively to an on-premise infrastructure, AWS infrastructure or cloud infrastructure is better. So that is a total overview of AWS infrastructure. Basically, AWS provides you and the cloud computing. Now, in this particular course, what we are trying to target our infrastructure is, what we are trying to design is, as a beginner to the cloud infrastructure, what are the things you need to consider? Because I know might of you, some of you are from the developing side background, some of you security, networking, and all these things. But on designing infrastructure in the cloud, you should know all the different parameters of infrastructure: administration job, uh, management of operating system, computing power, storage, and etc. So we have gathered all this information together. We have gathered all this AWS services together and created a course. So that is a solution oriented course where you will be able to design any infrastructures once you complete this particular course. So what we are going to cover is introduction to the basics of AWS. That is what we talk about, the regions, availability zones, and the edge locations. We are going to see in detail of it. Then we'll see the basics of the cloud computing, how cloud computing works, what are the parts of a cloud computing, and then we will map AWS services with this cloud computing environment, how AWS uses cloud computing environment to design the infrastructure to give you resources whenever you want. Then we have first security foundation service. This is really very important service when you are designing infrastructure. This is not a service basically. This is a particular resource which help you to manage your team members. Now, of course, you are not going to only the person who is going to manage the entire infrastructure. You will have your teams. So how will you give access to your team members to have access to your AWS infrastructure? So identity access management helps you to achieve that. It creates a users, it creates a roles, you can apply the permission what a user can have it access to, what a user cannot have. Because on AWS you have more than 150 services. So giving a permission to a user to have access to all the 150 services is not a good practice. We should clearly define what a user are responsible for, what are the roles it must have, and we should apply the roles only for that. If I have a developer, then I must give assigned developing tools only. Maybe EC2 instance, maybe the server only, and the storage only. If the particular person is from networking ground, from the security ground, then I must assign only those services. I should not give access to the entire AWS services. It's not at all recommended. So the basic security foundation service we are going to touch in IAM part. Then we have computing service, and computing service on AWS is called as EC2. How to launch a server, how to get a server of your own configurations, how to select an operating system, your own operating system, how to customize that operating system, etc. We are going to touch a lot of things in this particular computing section of EC2. And in the same EC2, we are also going to touch about the load balancer, elastic load balancer. If you have multiple servers, how you can balance the load between all the services. As well as we will see one of the amazing AWS service called as auto scaling. Autoscaling is one of the services which help you to scale your infrastructure up and down whenever you require. For example, let's understand a scenario of Amazon site. So we buy some products on the AWS, on the Amazon whenever there is a flash sale. So let's assume now you are also running an e-commerce site. And while you are running an e-commerce site, you know what are your target audience, how many targets you get hits every single day. Let's assume your target is approximately thousands requests per second. This is the amount of traffic you are getting per second. Now let's understand, tomorrow you have a flash sale on your e-commerce site. Big Billion Days, Amazon Great Indian Days, whatever they have, such kind of deals, such kind of offers you have. So of course, on this particular day, the number of traffic will be always twice, thrice, or more than that. Yes, so there will be an increment in the traffic. As there will be increment in the traffic, the resources which is required at the back end to handle all the loads will be also required. So you need to automatically increase the number of servers which is required. I have designed my infrastructure to meet thousands of requests per second. But now if I'm getting 2000, 3000 of requests per second, I need to update my servers to that limit. So autoscaling is a service which will help you to dynamically allocate the number of requests, the number of resources required to meet your demand. If gradually your demand increases, then the number of EC2 servers that you are running will also automatically increase to meet the demand. So your application will never fail to perform the response. You will never get error 404 not found, a server not responding, such kind of issues. You will always get a content. The server's capacity will automatically increase whenever there is a demand. And as soon as the demand goes down, once the flash sale is over, as soon as the demand goes down, the number of server which is automatically created will now be deleted automatically. So again, you pay for what you use. For the number of hours, the extra server we are running, you only pay for the number of hours. Once done, you don't pay for it. All right, guys, are you getting this one? This
Yeah,
example?
yeah. Going okay.
Okay, thanks. So the next part is our storage part. And in the storage, we are going to touch a lot of different kind varieties of storage system. What AWS offers you, varieties of storage like S3, Glacier, EBS, EFS, many more. What is the difference between all the different kind of storage system? Let's first take a EBS, Elastic Block Storage. It's just a normal block storage that you have right now on your computer, the SSD volume. It is nothing but a block storage. The data storage what we have on our mobile phone is a EBS, is a block storage. So block storage on AWS helps you to install your operating system, to install your application, and to store any variety of data you want. It can be an application data, it can be a log file, or it can be a media file. Any kind of data you can write on this EBS volume. And this particular EBS volume is completely persistent. Your data will always persist throughout the lifetime of this volume. If you want 2 GB of volume, you can have a 2 GB of volume. If you want 2 terabytes of volume, you can have 2 terabytes of volume. There is no limit. The minimum is 1 GB. Maximum you can grow a single volume to maximum up to 16 terabytes. And you have unlimited storage for that. So it's like a normal block level storage system, which can be used to mount to boot your operating system to run your application. Then the problem with the EBS volume, of course, one of the benefit we have seen that with this particular application, you can boot your operating system and run your application as well as store your data. But EBS volume cannot be shared across multiple EC2 instances at the same time. You can treat EBS volume as your pen drive. You connect your pen drive to one of your EC2 instance, one of your computer. You copy some data, you make some modifications in your data right into your pen drive, then eject your pen drive and apply to another computer. maybe for copying of a data, for moving of a data, whatever it is. So similarly, EBS volume also needs to be physically detached and attach it to another EC2 instance in case if you want to share your data. So in very short term, EBS volumes are DAS volumes, direct attached storage systems. This is physical storage system which is directly attached to your EC2 instance. Then you have EFS, Elastic File System, which is network as a storage service. The data is stored on one of the network in one of your storage system on the network, and this data can be accessed on multiple EC2 instances, multiple servers. Same like to your FTP server. You upload some data on FTP, and this data can be accessed on multiple computers at the same time. So same system we have. There's a file system available. You have to upload some data on this file system, and this data can be at the same time can be accessed on multiple EC2 instances. So for file sharing of a data, EFS can be used. The limitation of an EFS is up to a single network, which is called as VPC, Virtual Private Cloud on AWS. So the number of EC2 instances that you have on a single VPC, it can be extended to that limit. Now to increase the limit of how you want to access your data, there is a S3 service, simple storage service. This is basically an object-based storage system. It's a object-based. If you guys are aware of it, what is object-based storage system, then you must know what is S3 basically. Otherwise, object-based storage system is similar to your Google Drive or SkyDrive or whatever this iCloud Drive is. What you do, you upload some documents, you access it across the globe. There is no limitation who can access to the data, who cannot. You can make your data public, you can keep your data private, just like on your Google Drive. So same you have on S3. I can put my data on S3, I can share to any of one of you, even though you don't have AWS account, but still I can share a link with you and you can download the content of my S3 bucket. There is no need of AWS. So you can also download anything. If I share anything with you, a link, you can just click on it, you will be able to download it. Now why this is called as object-based storage system is, on EBS, on EFS, you can modify the content of a file. You have a permissions, you have a right to change the content of a single file. You can modify the file, you can update the file, anything you can do. But on S3, you cannot modify the content of a file system. If you upload .pdf file, if you upload .word file, then these file you cannot modify. If you wish to modify the file, you need to re-upload the file. The modified content you need to re-upload. Similar to your Google Drive. On Google Drive, if you have PDF files or if you have a Word file, you cannot directly edit the file. You don't have option. You have to re-upload the same file again for a modified content. So S3 is an object-based storage system. This is nothing but an object-based. So object needs to be re-modified, re-upload again to access the modified content. S3 data doesn't have any limitations. You can share this S3 link with any of your users, with your your team members or your customers, anything, and they people without having AWS account can access to S3 service, can download any file, anything. So we know what is where we can use EBS, where we can use EFS, and where S3 stand. These are all for the frequently accessed data when you want to frequently access the data. Then we have Glacier. As its name says, a Glacier is nothing but archival of your data. So if you have a data which is not required for a long period of time, then you can archive the data on the Glacier. Glacier storage system is very cheap. It will cost you $0.004 per GB per month. It is one of the cheapest solutions to store your data. but it comes with a condition that it is only for the archival data. Whenever you have a data which is not required for a long period of time, you can archive the data on Glacier. Because whenever you archive the data on Glacier and whenever you wish to have the data, it usually takes 3 to 5 hours to get your data. So if you request now, you will get your data in 3 to 5 hours. So that is only the condition. And that's why it's called as Glacier, and that is why the reason it is very cheap. So Glacier is for the infrequently accessed data for a long period of time. You can store your backup copies. You can store your log files on the Glacier to save your cost of storing the same information on S3 or EBS volume. You can save your money by putting this document, by putting this data on the Glacier. Because data is one of the crucial part of any infrastructure. You must always store your data so that you can protect and keep on the Glacier. Now coming to the next part of our infrastructure, that is networking, which is called as virtual private cloud. How to have your own customized network, the range of IP address, the number of IP address you require, and design your own network to have a communication within the network on the internet. How to design your public cloud, how to design a private cloud. We are going to touch all these things in our VPC section. And now comes the fourth important part is database. On AWS, there are varieties of database available. Now database, of course, you can design on EC2 because EC2 gives you computing power. On this computing power, you can install your operating system and then install whatever the database you want, MySQL, Microsoft SQL, Oracle, etc. But AWS offers you its own managed database system. So what is the difference? Having a EC2 based database or going with the Amazon design database? So in between these two, the differences are when you go with EC2, you have to manage your database by your own. You have to do all the administration job. You have to take care of the backups, etc. But when you go with the Amazon managed database system, Amazon takes care of your server. Creating a server, installation of components of a database, MySQL or Oracle, whatever it is, AWS take care of it. AWS manage the availability zones, high availability, as well as at the same time, Amazon also take care of your administration job, like patching your operating system, patching up your database, taking automatic backup, whatever the time you specify, once in a day, once in a week. Every time AWS will take a backup of this volume, backup of your database, synchronizing it to the failover policy. So these are the benefits that you get when you go for Amazon managed database system. Currently, AWS database management systems are limited to varieties of database like MySQL, Oracle, Microsoft SQL Server, MariaDB, and PostgreSQL. Second, for the NoSQL database, it is limited to NoSQL like DynamoDB. And recently, in the last week itself only, AWS has introduced Cassandra. So there are varieties of workloads available. Again, if you wish to go for a data warehousing options, then Amazon offers you Amazon Redshift, which is for the data warehousing options, where you have terabytes of petabytes of data and you want to manage these databases. At the time, you can prefer Redshift. It also have Elastic Cache. Elastic Cache is an in-memory data caching system. Instead of the data get cached to your client location, the data is now cached to your server side, to your in-house memory. So we will see all the different varieties of workloads, varieties of database in our system as well. So now these are the 4 core services of AWS. Now what we are going to see is AWS managed services through which you can design your infrastructure and access it easily. So the another service is CloudFormation. Now the services you can easily go to the AWS console and design your infrastructure easily on the AWS console. I will also show you now a demo on how to create a server, how it's easy to get a server. Now, CloudFormation is a service which is called as infrastructure as a code, IAC or IaaC. You might have heard of this name. So it's like you will write a code instead of going to the AWS console and design the infrastructure. You will write a code, you will execute that code, and AWS will design the infrastructure for you. Now you must be thinking, if you have a AWS console, you can design it by your own the way you want. Why one should prefer infrastructure as a service? So basically the funda is with going to the infrastructure as a code is, in case if you want to replicate your infrastructure, in case if you want to reuse your infrastructure to migrate your infrastructure in different region, or if any failover happens to your infrastructure, if any kind of failure happens and you want to restore your infrastructure, then the same template, the same piece of code can be executed again, and within minutes you will get your infrastructure up and running within only a few minutes. Let's take example of a food delivery system. Let's take example of Zomato. I'm not sure whether they are on AWS or what. Let's say they have designed the infrastructure on AWS cloud using this infrastructure as a code service. Right now, their service only relies in India. Now they wish to expand the infrastructure in, let's say, in Singapore. So of course they will require the same infrastructure in Singapore region. Instead of now copying each and every resources and then moving it to the Singapore region, the same template can be executed in Singapore region and they will get their infrastructure ready in only a few minutes. So any moment, if a company wishes to migrate the infrastructure from one region to another region, or maybe they want to upgrade their services in two different regions, they can do it within only fractions of minute. So it becomes very easy. It also be used for the disaster recovery purposes. So going to the CloudFormation is one of the best practices. Now we have seen how to design infrastructure, what are the components of this infrastructure. But once the infrastructure is ready, you need to connect this infrastructure with your domain, right? Because our endpoint will be always our DNS server, our domain name. So domain you can get with the AWS Route 53. On this Route 53, you can have your own custom domain. If you have already a domain, you can migrate to the AWS and you can manage your infrastructure. There are multiple routing policies available through which AWS will deliver the traffic to your services. Then we have CloudTrail. A CloudTrail is another security related services which help you to track the APIs made by your team members. The 10, 50, thousands of team members that you have on AWS, what they are actually doing, what services they are accessing, what kind of resources they are creating or deleting, everything what your team members are doing, you can track with your CloudTrail service. CloudTrail is specifically designed for tracking the users, tracking the what your users are trying to do, to check their activities, what they are trying to access the services. For that purpose, you have a security service called as CloudTrail. And then you have CloudWatch. Now, CloudWatch is a monitoring service to check what are the resources consumption you have done, how many servers you have, what is the utilization made by your servers, the amount of GBs of data that you have stored, the volume on S3 on EBS, what is the health of your VPC, what is the health of your EC2. All the entire infrastructure can be monitored with CloudWatch. Now, CloudWatch contains two packages. One, basic package, and second, detailed package. Basic package is always a part of all the AWS services. There is no any extra cost for having a basic package. For detailed monitoring, you have to pay a little extra. Now, what is the difference between a basic package and a detailed package? A basic package offers you logs in every 5 minutes. What your servers are doing right now, what is the utilization, you will get all the inside detail after 5 minutes. And in detail monitoring, you will get within minute. Within a single minute, you will get all the logs. That is the only difference. There are varieties of metrics is available. You can also have your own custom metrics. You can design the way you want. You can get a notification. Let's say my server, if it is running at 70% of utilization, I must get a notification so that I can take action. So on CloudWatch, I can create an alarms. Varieties of options are available. And then moving forward, we have the most important part for designing any kind of infrastructure is application services. These are the application services which really becomes a part of all the different kinds of infrastructure. It may be your financial side, maybe your banking application, maybe your e-commerce. You will definitely require this application services. The first application service is SQS, simple queuing service, right? A queue is always a part of a system. You always maintain a queue to design a distributed infrastructure, a better processing way. Maybe it's a banking side where all your transactions go to a queue where it checks whether the transactions made by you are correct or not, and then they process your data. Or whenever you buy a product on an e-commerce site, every time it has to be queue. So AWS has designed and given it to you so that instead of you work on designing and managing the queue system, AWS offer you direct integrated services which can be integrated to any AWS services. You can integrate it with EC2 or S3 or Lambda, whatever it is. So for storing of a messages for a short period of time, you can prefer a queue. Then you have SNS, which is a notification system, simple notification service. If you want to send a push notification, to your mobile devices, Apple, Android, or Windows, Firehose, whatever it is, maybe to your applications, mobile applications, or maybe to email, to via SMS, or to trigger HTTPS notification, you can use SNS. SNS can send a push notification to your devices. In our mobile phones, you frequently get the notifications, the maybe a news notification, maybe some other flash notification. Now these notifications again can be configured with SNS. Then you have SES, simple email service. If you want to send a bulk emails for promoting your code for your transactions that you make, right? Whenever we buy a product on Amazon or any other social sites, or whenever we buy even a tickets or whatever the transactions you do on internet, as soon as you do the transaction, you get an email receipt. So that email can be configured with Amazon here. So I guess now by this time you have a complete overview that you can design any infrastructure on the cloud, and whatever the services required on the designing a cloud infrastructure, you also have a supporting application as well that you can easily integrate and design the infrastructure. So if you want to design an e-commerce site, then what are the resources you will require? Starting with the IAM service, of course, you will have to share the credentials with your team members so that they can also work on AWS. So we'll start with the IAM. Then we will enable the CloudTrail so that I can track what my team members are doing at the high level. Then starting with EC2, I will design the servers, working with the VPC to design the networking at the backend which is required. And again, with the same time, I will have EC2, the number of servers, a load balancer, and an autoscale infrastructure. Now to store the images, to store the static content, I can prefer S3. I can store my data on S3, and what applications I want to run, I can run on EBS volume in conjunction to the EC2 instance. Then the entire infrastructure, I will domain it with my Route 53 service. And then with the CloudWatch service, I can monitor all my application, the amount of utilization I'm doing, the amount of targets I'm getting, etc. And with this application service, I can remove the load, I can get rid of just designing such kind of application, and I make a more distributed application to interact with my customers easily, to make my customer experience better with the proper queuing service, where their transactions will not be deleted or terminated. With the notification service, they will easily get notified whenever there is update in any system and any changes they want. And with SES, I can easily indicate and give them share response. So this is all about how you can design your infrastructure and conjunction to all the services, how you can have a better user experience with your cloud infrastructure. Now we are going to touch about the amazing most used AWS service is Lambda. Now before I go to the serverless services, let me just give you a small idea about. We know what is server. A server is nothing but a computer which is we are going to access this now over the internet. So of course, if I'm running an e-commerce site, I have to run that server 24/7. No matter how many targets I am getting, no matter how many traffic you are getting, you have to run 24/7 the server. So you pay again for 24 hours. Now we have a serverless computing. As its name says, this is a serverless. So there is a no server running. You will not create any server. You will not at all have a server. You don't have to configure it. You don't have to maintain it. AWS at the backend will take care of it. Now, as there is a no server, so you don't pay for 24 hours. You only pay whenever a request is made to your Lambda function. If the entire period of 24 hours, if a span of 24 hours, if you get only, let's say 100 requests or 200 requests, so 100 requests execution will only get cost to you. You only have to pay for those 100 requests. And each 100 requests, how long it took to execute that request. 100 millisecond, 200 millisecond. So 200 milliseconds into 100 requests, that is how much you need to pay. That's it. Whenever your servers are idle, whenever there is no request coming, you don't pay anything. And what AWS offers you is every month you get 1 million requests per month for free. AWS offers you 1 million requests per month for free. You will not get charged for that. Post 1 million requests, you get only 0.10 or 0.1 dollar per another 1 million requests. So it is one of the most cheapest options available. There are a lot of things we need to discuss about it. You cannot have your front end on a Lambda. It can only support your back end job. So there are a lot of things which we are going to discuss in our course sections of course. That is basically a serverless. Then you have Elastic Beanstalk. This is a platform and service you can consider. It's like you will have to create a server, you have to do the load balancing, you have to create a database, you have to create a VPC, you have to connect with your storage and do the entire infrastructure, right? When you go to the manual design of infrastructure, you have to do all of these things. So Elastic Beanstalk is just a CloudFormation template where you can configure what kind of infrastructure you require, which operating system you require, the amount of servers you require, and Amazon at the backend will design the infrastructure for you. The number of servers, the VPC, the database, the S3, everything it will design at the backend, and it will offer you a direct product. You have to just upload your code, you have to just upload your application, and you have a ready infrastructure available. So that is Beanstalk. And lastly but not the least, the most amazing service, the most widely used service, CloudFront. May I know anyone having idea what is content delivery network? Anyone having idea about what is content delivery network?
Yeah, it's like Netflix, Hotstar, and all those things. Yeah.
Yeah, what it actually does.
So it serves the content to the subscribers. Yeah. So
Correct. So basically, content delivery system is something that the data will be cached somewhere, and if the data is frequently used, the user will get the cached data. So, for example, whenever we get the data from Netflix, whenever we try to pull some movies, some series from the Netflix, basically the data is already cached in our Indian infrastructure. Though the Netflix entire infrastructure is designed in US, now the data, the movies and everything is being cached in the Indian region. So when I request to the Netflix, I want to watch this particular movie, the request goes to the CloudFront, and CloudFront checks whether the data available in Indian region or not. If the data is available in Indian region, it will forward me that content. If the data is not available in Indian region, then it will request the data from the US server and it will forward me the data as well as at the same time it will write the data in the Indian cache location. So that the next time anyone requests to the same data will get the content from the Indian. So what happens basically, if for me, if it took to go to the US region, get some data, let's say 400 millisecond, for me to travel to the US, come back with the data, let's say it took 400 millisecond. Next time any person tries to fetch the same data, will get the data in 100, 150 or 200 millisecond. Of course, that will be less than 400 millisecond, what I require. So to improve again the user experience to get the huge amount of data in a lesser period of time, you have a CloudFront technology. And you will be get amazed, but all the big media related companies are using the CloudFront network. Netflix, Amazon Prime, Instagram, Pinterest, Facebook, these all are working on CloudFront. Even your Apple, Samsung, MI, the mobile update that you receive are also dependent on this CloudFront network. Whenever you get an update, you basically download the file from the nearest cache location. And across the world, Amazon edge locations are available in 169 different regions. So if you are designing a particular product and the particular product needs to be having a CloudFront network, then this data will be cached in 169 different locations. So how quick and how good the user experience will be. So we will be discussing more on this CloudFront network. This is really very important service. You can also have the static as well as dynamic data on a CloudFront. It is pre-packaged with DDoS attack, MySQL attacks on all this. It got all the prevention methods. So nothing to worry about that at all. So that is what we are going to discuss about the CloudFront. And lastly, we have well architecture framework. That is, once you gain all this information, now how to connect all the dots together to design a best suited cloud infrastructure. How to connect EC2 is EC2 S3 VPC all together to get and what are the best practices that AWS offers you by the different solution architects and everything that we are going to discuss in the well architecture framework. All right. Any questions, any doubt, guys? Any questions
no,
we have? Let me know.
no, it was nice session. So are you done with it, or so are you opening for the question and answer?
If you guys want, then I can show you a demo on how easy it is to create a EC2 instance.
Yeah, let's do that. Yeah, and then we have some questions, so we'll ask that. Yeah,
Sure, sure.
thank you.
So you can see this is my AWS console. I have logged in already to the AWS management console. And these are the all AWS services which you can see here. These are nothing but AWS services. So here you have computing services, varieties of services available, blockchain network, storage services. You have a list of different databases, migration services if you have from on-premise to AWS, network and content delivery system. If you are going working on a big data or analytical services, there are varieties of services again available. For machine learning and media services, a lot of again services are available. So for a different perspective, for a different applications, you have a different services for IoT, etc. So I'm going to show you a quick demo on how easy and how fast it is to get a server on the cloud. So I go to my EC2 section, and right now you can see I'm in Mumbai infrastructure. I'm designing this infrastructure in Mumbai. And these are all the infrastructure where I can design my infrastructure. If you want, I can design in North Virginia, Ohio, California, anywhere I can go. So let's launch an instance. Click on launch instance. From here, you can select an operating system, whichever you want. It's a Red Hat based operating system. Then you have SUSE Linux, Ubuntu, or Microsoft Windows. Whatever you want, you can prefer. I'm going with the Red Hat Amazon design. And this particular machine, the amount of hardware I want. So you can see a very big list of hardware available with different configurations. 1 core CPU, 1 GB RAM, 1 core CPU, 2 GB RAM, etc. Varieties of workloads are available. Based on your workload, you can choose. Then let's configure a few things. Here, I don't need to do anything to as of now, any changes. Then I will just add storage for my booting up a system, and minimum requirement is 8 GB to run a Linux based system. So I go with the default one, add tag. Let me just add a tag. Okay. Having a tags plays a very important role. You must have it always. Then what security keys I need to import on my security group? That is, I named as Linux security group, and which ports I need to open. Let's say I want to open SSH and HTTP, and I will just open this port to my IP. That is, whenever I want to access to my server on port 80, only this particular IP address, that is my particular IP address, will be accessible. You cannot connect to my device. You cannot connect to my server. So I've just make sure that the restrictions is available, and I can add multiple rules here. This is basically a security part. Then I just click on launch an instance with my key pair. That is my authentication method. And it says Linux XG is available already. So I will just change the name, review, and launch. And you can see within only few seconds, you get your servers ready. It is right now in pending state. And here you go. You got your instance ready, up and running. Whatever the applications you want to install, you can just connect to this service and get your system run. Now, if you want to connect to this service, you have to just copy the public IP and open your terminals or putty, whatever you have. And I'll show you how you can connect. Just pass a normal command, ssh-i, the keep here, your username at the right IP address. And you have connected to your operating system. Whatever you want to download, whatever you want to configure on your machine, this is right now available with you. Root at the right IP 172.31.16.155, which is nothing but your private IP address. So you have connected to your server, a cloud-based server. It's very easy. Let's say you want to install the Apache server to configure your website. So yes, install, yum install httpd-y. HTTPD is nothing but a package name for your Apache server. I just install the Apache server and I start the service httpd start. And then in my var w.html document, I will write a simple index.html file saying h1 Okay, I'm just giving a small message. Hey, this is a AWS session. And I save this file. You can see I have an index.html file. Now, you got to know how easy to get a server, how easy to connect a server, and to configure the details that you want. Now, it is as simple as if you want to access this data. What you have to do is just copy this public IP and hit from the browser. As soon as I hit from the browser, I can see the content of my easy to install, the content of my web applications. I can install any HTML document, I can host my application, I can have access. But now, you can see this IP address. If you try this IP address from your console, from your browser, you will not get the data. I'm sharing this link with you, this IP address over the chat. Just click on it and try to access data. You will not get it. Anyone trying? Are you getting the content?
Yeah, I'm trying. Just 1 minute.
You will not get, right? You're not getting.
No. Yeah, it's not accessible.
No. Now, I go again back to my security group. And if you remember, we have created a security group that 80 port is only accessible to this particular IP address. So when I'm trying to access this 80 port over the data from 80 port on this particular IP address, I am getting data. But as you don't have this particular IP address, you are not getting the data. So as soon as I just make a changes to this particular IP address in this particular security group and make it as custom, and I give it as 0.0.0.0.0 means anyone on the internet. And as soon as I click on save, now you guys can try from your web browser, you will get this content.
Yeah, I got it. Thanks.
Yeah. So you can see having a security management of a security is as easy as doing a few clicks. Same, you have instances, you have security groups, you have load balancer, auto scaling, everything just on your phone. You can access whatever data, you can provide the security. So nothing to worry about the security, though you are on a public cloud, though you are on AWS. AWS offers a varieties of security features. You can connect, you can have a security at all layers. Right? So now let me know if you have any questions. I'm just terminating the server, so I will not get charged. Yeah.
Okay. So couple of questions. One thing is normally the participants ask that in your detailed session, how long that detailed session would be, and whether you are flexible to do, like, let's say a couple of hours on the weekdays and few hours on the weekend or something like that. Yeah.
Okay. First of all, this entire course contains approximately 80 to 85% of lab sessions. So as just now I created a servers in our training program, you will also have your own server, you will also have your storage and everything. And the best part is you will not get charged. If you just follow my instructions, you will not at all get charged. Whenever you create a AWS account, you get a 1 year of free tier subscription. In that part, if your limited resources are available, if you remain within the same resource limit, you will not get charged. So in this particular session, in this particular training program, you will be having approximately 70 to 80% of lab sessions. So what we are talking about, the server, the storage, you will also have it. So the entire process, the entire training goes approximately 25 hours of time, because it completely depends on how easily you get this part, infrastructure, storage, and other things, how you will be able to understand the scenario. So that is not restricted. If you require more hours, then we can just have a 1 or 2 hours in the buffered mode, so that all your doubts will be, of course, clear. And then let's talk about the training sessions when we are going to have. It's totally up to you guys. If all are comfortable for the weekend, morning session, weekend evening sessions, then we can conduct at the time. If you are good to go with the weekday morning and evening, we can go. Basically, normally during the daytime, we are all busy in our work. So I hope like everyone will not be comfortable at that time. So whatever the time we can have decided or single time, we can do all these lab sessions.
Okay, thank you. Thank us. Any
Yeah.
question? Any other question, guys? So let me stop the recording and